generic vocabulary for the circle unit that we're entering. So the first one is central angle. It says an angle whose vertex is at the center of the circle. So I've sketched a little circle for you. You put a center in there and draw any kind of angle. So an angle is going to extend. There we go. There's a central angle. An angle whose vertex is the center of the circle. Okay, we're going to keep moving whether you're with me or not. All right, number 2, an inscribed angle is an angle whose vertex is on the circle. So we can have any 2 chords, and I'm going to jump down here to chord definition. A chord is a segment whose endpoints lie on the circle. So all you'd have is 2 little endpoints on the circle and connect the dots. Okay, an arc is an unbroken part of a circle. Minor arcs have a measure of less than 180 degrees. I'm just going to sketch in a quick minor arc. We just pick a point, start, stop. There we go. There's a minor arc, less than 180 degrees. If it's exactly equal to 180 degrees, it's called a semicircle. And if it's more than 180 degrees, it's a major arc. We have different ways of naming those. We'll talk about that when we get to them. The next one, tangent line. It's a line in the plane of a circle that intersects the circle in exactly one spot. So let's sketch a tangent line real quick. So it's a line. It needs to extend forever in both directions. And it touches the circle in exactly one spot. Tangent.
We talked to draw. Almost involved.
All right. The next one is a secant line. A secant line passes through 2 points, so you could really draw it any way you wanted. There we go. There's a secant line.
Now, I have a question. Oh, no, because it has to be a full line. So the tangent line, it can be like a ray.
You can have a ray that is tangent.
Sure.
Wait, tangent. That's like tangent.
So I was just thinking about
like tangent on the calculus. Yeah, it's like.
This is tangent in terms of geometry, and it means it touches in exactly 1 point.
Dang it.
But I do like the way you're connecting dots. Okay, the last one is a tangent segment.
It's the last sequence.
A secant segment. So it's going to
Shouldn't it go all the way?
contain a chord, and then it's going to have an endpoint outside.
So does it? Okay. So it doesn't have it only has one endpoint on the circle.
Yeah.
Correct.
I was thinking about how like an extra point there. That wouldn't be an endpoint.
Hey, you didn't win through first.
Are we good?
Yeah. My sister asked what powder is it?
You did that,
All right.
Staring at me.
I hit mine too.
It's out. I'm so done with this random thing.
Okay, for some reason, I forgot to draw the circle here. So you draw your own circle in the next one while I cheat and use a circle drawer. There we go.
Cheaters never prosper.
Teachers don't either, but. Alright, an inscribed polygon is a polygon whose vertices lie on the circle. So you can make any kind of polygon you want. Okay, I'm not doing a very good one here.
It kind of looks like an inside.
There we go. Right now it does. I'm not done with it.
You don't? No?
I did too.
Well, it's an order.
Ooh, yours looks better. Alright. I made a whoppy-sided pentagon.
Thomas Evans.
Okay, the next one, inscribed circle. We actually talked about inscribed and circumscribed circles already. Inscribed is in. So let's see if we can draw these tangent lines.
Nice you.
Thank you.
And why you guys talking in English accent?
Why not?
Because you have an American accent. And
No, what is an American?
What? Yeah, really.
What is an American accent?
Yo, what's America?
Everyone who lives in America doesn't have the same accent.
America. That's American. Did you say American when you
America.
Okay, y'all do this and quit being silly.
yeah.
This is much harder.
By Alexis Neeson.
Sorry, I can't help it.
It's all your fault, Alexis.
Just because you see
Dang it. And what's the meaning of life?
Okay. Alright guys, y'all are boring Connor right now. Alright.
Wait, Connor can hear all this. He'll be able to.
Okay, so the circle is inside. And then the last one, circumscribed, so it's triangles inside. Okay, close, but not quite, but we'll pretend. Okay, arc length. Well, that's just where we take the arc, any arc, and we find its measure. The measure of the arc. How long is it? Arc length. So the name kind of defines itself. It's the length of the arc.
Oh, I get it.
Arc length. Alright, sector is like the piece of pie. So if we add a piece of pie, sector,
Inscribed animal.
right in there. Like a piece of pie. That's a little piece. You could have a big piece. Or a pizza.
Or a circular
Or a
cake.
pizza.
Or a piece of cake. Or lots of things circular.
Or a block of cheese.
I like. Well, it'd be a wheel of cheese, wouldn't
Oh, it would have to be
Block
a
of cheese is a block.
No, this is a block.
Okay,
It would be a very.
so today we're going to add one thing to our definitions today, and that's going to be talking about proving similarity. Now, we can prove similarity two different ways. The first way we're going to look at it is using our transformations. Now, to prove similarity, which transformation helps us with similarity versus congruence? Dilations. The dilations is what's going to define the similarity. So, a similarity transformation is a dilation or composite. What that means is a combination. Let's see. A combination of a dilation with a translation. Those would prove that they are similar. So here we have two circles. This one's at the center. It has a radius of 1. The other one, its center is at 0, 6, and it has a radius of 3. We're proving that. Yes, they are, and let's prove it.
Why do we have to prove it?
Because you signed up for this class.
I did not.
Oh, I didn't say
Yes,
it.
you did.
My mom's
All right, so
Decent sized spot.
I can tell just not looking at it.
what dilation takes us from this circle to this circle?
3.
A dilation of 3. Okay, because it went from a radius of 1 to a radius of
2, 3.
3. Okay, and then it's going to take a shift. So what's our translation?
Up 6.
Up 6. That should be the word's units. Okay, so this is how we can describe it in words, which is what I'm going to make you do. Describe it in words. Could we also write the rule? Yes. We take xy, 2, we dilated it by 3, so it became 3x, 3y, and then we shifted it up
6, so
plus
3y plus 6.
6. Okay, let's see if that works. If I pick the point 0, 1 on this one, shouldn't it correspond to this point, which is 3, 6? If I plug in 1 here, did I say 0, 1?
Yeah.
I meant 1, 0. If I plug 1 in here, what do I get out? 3. And if I plug 0 in here, what do I get out? 6. So did it shift this point to there? And I could test any point on here, and it would shift it to its corresponding point. Are we good? it would work.
What if it was like one that wasn't
What
right
if
on
we
it?
stop
What if this
saying
isn't a
what
real
if?
school? That's kind
Okay,
of the point.
well,
What if communities?
these were all irrational in between here. We would have to start with by finding the point, which is irrational, and it's ugly. But we could. Yeah, we could.
The point has feelings too.
It does. All right. So, it said it in words here. We'd shift up 6 and have a dilation. All right. Now, this one's a little trickier. Little trickier. Because our original one does not start at the center. When we did dilations that did not originate from the center, what was the first thing we had to do? Shift it back to the center. So the first thing we would have to do is take my original one and shift it back to the center, which would be what? Well, that's good. But then how do you get -3 to 0? Plus 3. Okay? What type of dilation takes us from a radius of 2 to a radius of 5? 2.5. Or 5 halves. So then when we dilate by 2.5, or 5 halves, so this would give us, you could write it like this, 5 halves x, and then 5 halves y plus 3. You could write it that way too. All right, and then how would we shift it back to 5, 1? We'd have to add 5, and then add 1. Woo, that's ugly, isn't it? So what I'm going to do, because these get ugly, and we lose understanding halfway in the middle. How many of us sort of got lost around here? Okay, because that's going to happen. I'm just going to let us write the words on these more difficult ones. So, what is the dilation?
2.5.
A dilation of 2.5. And what was my translation? How do I go from here to here? A dilation right 5. And up from here to here, 4. I'm not going to make you write the rule.
Thank you.
Okay?
Okie dokie. Wait. Never mind.
All right. So take a look at the back of your homework. I mean, back of the worksheet. I just want you to write the words. What was the dilation? What is the shift? On 1 through 6. Dilation, shift. Dilation and translation.
Bless your soul. It is.
It's 2.2.
Yeah, we're going from under the 6 up. Then it's up to the
Congratulations, you're a doctor. Actually, that was your prescription. That was the prescription you did. You get it. That's good.
No, radius of 4.
What's the deal?
Oh my goodness, I see it.
Oh, jeez, all of them. Oh.
Okay.
And then we write it.
Chips, penny or chips, whatever. Okay, so eggs come alive.
Dude, that's some bold stuff you got on.
Yeah, I know. I got them in 2.25.
Cut it off when you do.
Or you could just say,
You can have so much nice stuff.
you just were $6. $5.99.
Oh, yeah. Whatever.
Giant rack.
What? That's what I put.
That's what I put, like $2.
That's what I put. What is the fancy one?
Basically, like,
Okay, so
what's the deal of number 6?
That says Brian. Dialimation. Wow. I'm tired. I'm very tired. He was having an allergic to pollen, so this is very unfun for me.
Me too. I have to take my allergy medicine every morning and do this nose squirties every night.
Seeing it in the air, I know I'm gonna have a headache that day.
No, wait, I think
Okay.
Pudding and cheese. That's basically been my diet.
oh, it's a dilation by small letter. Yes, you're right.
Okay, so the first one is a dilation by what? 2. A dilation, actually, if we actually wrote it out, it would look like this. A dilation by a scale factor of 2.
Oh, that's a lot.
And a translation,
Do you want us to write the word translation?
right 3 and up 1. Okay, so let's use some shortcut here, shorthand. Dilation of a scale factor of
3.
3. And what was our translation?
The 14.
Left
Wait,
2.
in number 1, don't you go left?
Up 8.
Yeah, left 3. Thank you. So this one is left 2 and up 8. This one is a dilation of
2 1/4.
2 1/4, 9/4, 2.25. Those are all the same thing. And then we would say right, translate right 2 and down 4. Okay, this one is a dilation by a scale factor of 1/5. And then we go left 4 units and down 4 units.
Yeah.
This one is a dilation by a scale factor of 2/3. It is left 13 units and down 28 units. This one is a dilation by a scale factor of 4/7.
Sorry.
It is left 3 units. And that's it. Any questions? Okay. Algebraically, if we looked at any 2 circles, where's
They are
mine?
similar.
To show that they're similar, we could do something as simple as this. Where's my circle maker? Okay. I'm going to put in radii that aren't perfect. Yeah, that's bad. I think because that's not a circle.
The architecture was not free.
It's not a circle.
Isn't it, Wolf? Huh.
Maybe it's the angle that you're at.
Maybe it is. See, these two links should be the same, and they don't look the same to me.
Look about the.
Do they? That one looks good. All right. So if I were to come up with the ratio, the radius of circle 1, we'll call this circle 1. We'll call this circle 2. So this would be the radius of 1 to the radius of 2. And that gives us a ratio. Now, let's compare that to the diameter of the first one. Well, if the radius is R1, how could I describe the diameter?
D1.
2 times
2R1.
R1s. And how would you describe the diameter of the second one? 2 times R2. Okay, this ratio simplified to? Same thing. Okay, now let's look at circumference. Circumference is 2 pi r. So 2 pi r.
Wait.
2 pi r. So if I did circumference of the first one to circumference of the second one, what does that simplify to?
1.
The same ratio, doesn't it?
Isn't that 1?
Or, let's say I even looked at this chord here. This chord compared to this chord. I drew it in terrible.
Oh no.
But it should make right triangles.
Oh yeah. Oh no.
Isn't this a 45, 45, 90?
Yes.
Yes, so if the leg is R1, then the hypotenuse would be R and root 2. If the leg is R2, this would be R2 root 2, which sounds a lot like R2D2.
R2D2.
By the way, the Star Tours is actually better than it used to be. So if
What
you
is
haven't
Star
been to
Tours?
Disney in a while,
I've never
now
been
that
to
you
Disney.
have it with the 3D glasses on, it's better.
Did you go
I've
to
been to
Harry
Disney
Potter?
It's
Disney
better.
on that.
That's
Disappointing movie number 6.
It used to be worse.
Like right there. Yes.
They're both in Orlando.
They're not like the same.
Miss Woman, did you? Miss Woman, did you
All right.
go to Universal?
All right, any questions? Okay, what we're going to do at this point is I'm going to give back your test and we're going to look over those. And then you can have time to start your homework. Oh, your homework is a small test of the USA Test Prep. So go to USA Test Prep, go up to the top where it says EOCT, click on that, choose coordinate algebra. Okay, guys, he's not going to be able to hear me. So log on to USA Test Prep, click on the tab that says EOCT, choose coordinate algebra, and then choose small test.
Yes?